Hi guys, so in this video what we're going to do is look at the chain rule. In this video I'm going to give you all the shortcuts. If you want to know how to do it using the classical U method, then check out the other video on my website. Okay, so what we have here, chain rule, you can see here I've got four things. It says bring down the power, rewrite the bracket, take one off the power, differentiate the bracket. Okay, so if you have a look at an example here, anything that we have a bracket to the power of something, we can use this sort of mantra. So bring down the power, rewrite the bracket, take one off the power, differentiate the bracket. So if I want to find the differential of this, it's a chain rule because I have a bracket to the power of something. So what I do is I bring down the power. So let's write dy dx first. So bring down the power, so the 5 comes down to the front. That's equal to 5. And then the second bit is rewrite the bracket. So if I rewrite the bracket, I get x squared plus 6. Take one off the power. So have a look, see what the power is. The power is 5. Take away 1 is 4. And the last thing I need to do is differentiate the bracket. And the bracket is here, is x squared plus 6. And if I differentiate that bracket, the differential of x squared plus 6 is 2x. Once I've done that, I tidy it up a little bit. You can see I have 5 times 2x, which is 10x. So 10x, x squared plus 6 to the power of 4, and that's it. If we have a look at example 2 here, we can see I have y is equal to sine to the power of 4x. So y is equal to sine to the power of 4x. We can rewrite this, guys, as y is equal to sine to the x, sine x to the power of 4. It's exactly the same. These two things, as we know from the trig section, mean exactly the same thing. We now have a bracket to the power of something, just like over here, this was a bracket to the power of something. So that means we can use these 4 stages again to solve the differential. So dy dx, and the first thing we have to do, bring down the power, so the 4 comes down. Let's write that down now, so 4. Rewrite the bracket, sine x, take 1 off the power, 4 take away 1 is 3, and differentiate the bracket. The bracket here is sine x, and the differential of sine x is cos x. So let's write that down. Then tidy it up. So we've got 4 cos x by sine cubed x, and we are done. So bring down the power, there, rewrite the bracket, take 1 off the power, 4 take away 1 is 3, and then differentiate the bracket. Differential of sine x is cos x, and like I said, it's just tidied up. Okay, let's have a look at this example. It says, if y is equal to the square root of 2x squared plus 1, find dy dx, and show that it can be written of the form 2x over y. Okay, so essentially find dy dx, and hopefully we can sort out the rest of it later. Now hopefully we're happy. We can rewrite this as y is equal to 2x squared plus 1 to the power of a half, because if you remember from your index laws that the square root we can write as the power of a half. Okay, so that's where that comes from. Notice that we now have a bracket to the power of something. That's the chain rule. So we're going to write dy dx, not a bother, is equal to bring down the power. So that's a half. Rewrite the bracket, 2x squared plus 1. Take 1 off the power. A half take away 1 is minus a half. Differentiate the bracket. So that means what we have there is 4x. Okay, I'll go through that again. Bring down the power, so that comes to the front. There's the half. Rewrite the bracket. Fair enough. Take 1 off the power, so a half take away 1 is minus a half. Differentiate the bracket. So if we differentiate 2x squared, we get 4x. If we differentiate the 1, we don't get anything. Let's just tidy it up as much as we can. So we now have dy dx is equal to, hopefully you can see that that 2 and that 2 will factor out, which now means that we have 2x, and then what we have then is 2x squared plus 1 to the minus a half. Now, looking here, this is to the minus a half, so what we can do is we can take it underneath. because of our index law. Remember, the index law says that a to the minus p is equal to 1 over a to the p. So if it's a negative, we can take it underneath. So let's do that next. That now means we have 2x over 2x squared plus 1 to the power of a half. We can now change this back to the square root because of the half. So let's do that next. So we end up with 2x over the square root of 2x squared plus 1. And we were trying to get 2x over y, but hopefully you'll see that y here is equal to the square root of 2x plus 1. So wherever we see 2x squared plus 1 here, the square root of, we can replace it with a y. So that means that we can change the bottom for the y, because hopefully you can see that y is equal to the square root of 2x squared plus 1 up here. And we're done. Okay, so the last thing I want to talk about is the trig functions with chain rule. And again, we're going to do the quick method. So you can see here that what it's telling you essentially to do is this. You differentiate the trig function, keeping the angle, and then what you do is you differentiate the angle and multiply them together. Okay, so I'm going to go through that with these 4 examples. So the first one here, y is equal to sine 4x. We know that sine x goes to cos x. That's just one of the differential rules. So we've got to keep the angle. So sine 4x will go to cos 4x. Okay, so cos 4x. Then what we do is we look at the angle, which is 4x. We differentiate the angle. The differential of 4x is 4, and we multiply that there. And that gives us dy dx. Just let me go through that again. So we know that sine x would go to cos x if we differentiated it. Sine 4x goes to cos 4x, and then we have to differentiate the angle. The differential of 4x here is 4, and we multiply them together. Let's look at the second one. So we have y is equal to cos of 3x squared minus 2. So we know that if we differentiated cos of the angle, it would go to minus sine of that angle. So cos of 3x squared minus 2, the differential will be minus sine 3x squared minus 2. But then we have to differentiate the angle. The angle here is 3x squared minus 2. So the differential of 3x squared minus 2 is just 6x, because that will disappear. We then multiply it by 6x, so what we have is 6x. And we then tidy it up, minus 6x sine of 3x squared minus 2. And don't forget to put dy dx is equal to that. Part 3. It's the tan one. So we have y is equal to tan of 1 minus x squared. Dy dx is equal to, well again look, tan of x would go to sec squared x. So what we do, tan of 1 minus x squared will go to sec squared 1 minus x squared. But we also have to differentiate the angle. So we have 1 minus x squared, and if we differentiate that angle, the 2 comes down, it's going to be minus 2x. So minus 2x, again, tidy it up, is equal to minus 2x sec squared 1 minus x squared. Just go through again. Tan goes to sec squared, so tan of the angle goes to sec squared of the angle. And then what we have to do is have to differentiate this angle here to get the minus 2x. So how do I spot if it's a chain rule? If you ask yourself these questions every single time you look at a differential, you should pretty much spot every single time. So, first question I ask myself, is it a product? If it's not a product, is it a quotient? So product rule, quotient rule. If it's not quotient rule, is it exactly the same as in my tables book? It has to be exactly of these forms here, guys. If it's not any of these forms, then it's a chain rule. So if you have a look here, example number 1, 2x plus 1 to the power of 4. Does that look exactly like one of these? Is it x to the power of n? Well, no, it's 2x plus 1 to the power of n. It's not exactly the same as that. therefore this is a chain rule. And then you use the whole idea of bringing down the power, rewriting the bracket, take one off the power, differentiate it. Is this a chain rule? Well, it's not a product. It's not a quotient. Is it exactly the same as one of these? It is, so you can just write down the answer. Let's have a look. Sine 5x. Again, it's not a product. It's not a quotient. Is it exactly the same as in my tables book? Well, it isn't. The tables book says sine x. This is sine 5x. Therefore, it is the chain rule, and you use the trig chain rule sort of cheat that we did in the previous slide.